Pre-statistics. Formulas. Lesson objectives. Use formulas, or sometimes known as literal equations, to solve various types of problems. Solve a formula for a variable. Lesson objective. We'll begin with the definition. A formula, or a literal equation, is an equation involving two or more variables. Let's look at an example. For a rectangle with length L and a width W, area, which is denoted capital A, and perimeter, capital P, the area of a rectangle is A equals L times W, and P equals 2 times L plus 2 times W. Both these are an example of formulas or of literal equations. Let's do an example. Example 1. An architect is designing a school building so that each classroom contains 35 student desks. Fire code requires that there will be 18 feet per student desk. If there is enough room for classrooms of length 28 feet, what is the smallest width permitted by the fire codes? So for this solution, to find the area of the floor of one room, we multiply the area needed per student desk by the number of student desks. So code says it has to be 18 feet. We have 35 desks, so 18 times 35 is 630 square feet. Now we need to find the width of the rectangle of 630 square feet and a length of 28. Now that's a good idea to go ahead and draw a picture. So this area here is 630 feet. The length is 28 feet. We need to find W. So we take the formula, A equals L times W, and we substitute the two values that we know. And then we solve for W. So area equals length times width. Area is 630. Width is 28. So we have an equation. To get W by itself, we divide by 28. And we have the width being 22.5. So the smallest width permitted by code is 22.5 feet. In general, to find a single value of a variable in a formula, we often substitute numbers for all the other variables and then solve for that variable, just like we did in the previous example. Example 2. A landscaper has budgeted enough money for 100 feet of fencing to enclose a rectangular garden. If the length of the garden is to run the full length of the property, which is 37.5 feet, what would be the width of the garden? It's always a good idea to draw a picture. So this time we're given perimeter, which is the distance around, so this length plus this length plus this length plus this length will have to be 100, and then we're going to solve for W. So if we substitute 100 in for perimeter, P, and 37.5 for L, in the perimeter formula, we have this equation. We're solving for W, so the first thing we want to do is multiply these two, and we get 75. So to solve this linear equation, we need to get rid of the 2 and the 75. So since the 75 is adding, we're going to subtract both sides. And we end up with 25 equals 2W. Now we divide by 2. So the width of the garden will be 12.5 feet. Here's another formula. It's called the total value formula. And if we have n objects, each have a value of V, then their total value, which is denoted T, is given by the formula T equals V times N. Now this is again a literal equation because it has two or more variables. So in words, the total value is equal to the value of one object times the number of objects. Let's look at an example. Example 3. In 2009, Chicago Cubs baseball tickets for upper deck, reserved seating, and the outfield at Wrigley Field cost $16 each on bronze dates. Number 1, find the formula of the total cost, T, measured in dollars, of N of these tickets. Number 2, perform a unit analysis of the formula found in Part 1. And lastly, number 3, substitute 80 for T in the formula from Part 1 and solve for N. What does this mean in this situation? We'll begin with number 1. We substitute 16N for V, the value, and then we multiply that by our variable N. So our formula is T equals 16N. Number 2, to do a unit analysis, T is measured in dollars. 16 is dollars per ticket, and then N is number of tickets. So the tickets cancel, and we're left with dollars equals dollars, so the unit analysis checks. Number 3, we begin with our formula. We substitute 80N for T, and we solve for N. So we divide both sides by 16, and N is equal to 5. Now what does this mean in this situation? So the total cost of 5 upper deck reserved tickets at Wrigley Field is $80 on the bronze dates. Less objective. Example 3. Write the equation 2x minus 5y equals 10 in slope-intercept form. And if you recall, that's y equals mx plus b. We want to isolate the y. So that means we need to get rid of the minus 5. We need to get rid of the 2x. So what do we do first? Well, we can think of this term as a number. And we have a number here. Since the 5 is multiplying, since this value is adding, we want to get rid of this value first. So we're going to subtract 2x to both sides. These cancel. We're left with negative 5y equals 10 minus 2x. And of course we can write it negative 2x plus 10. It's the same thing. Now the reason why we want to write it this way is because y equals mx plus b. The x is the first term on the right hand side. Now we need to get rid of the negative 5. Since it's multiplying, we do the opposite and divide. And we have to remember to divide both terms on the right hand side. And we're left with y equals 2/5 x minus 2. If you recall, the area of a triangle is given by this formula. A equals 1/2 base times height. So area equals 1/2 the base times the height. So here's the base. Perpendicular to the base is the height. So if the area is equal to 100 and h is equal to 10, what is the value of b? Well, we start with our literal equation, our formula. We substitute the values in that we know. H is 10, area is 100. Now all three of these values are multiplied, so it doesn't matter which order I multiply them. So I'm going to take 1/2 times 10, and that gives me 5, which is times b equals 100. And if we divide by 5, we see that b is 20. Example number 5. This is the formula for the area of a trapezoid. So here's a picture of the trapezoid. There's two different bases. One is labeled A, the other one B. Here's the height. And we want to, for part A, take this equation and solve it for h. So we begin with our formula. To solve this for h means I need to get rid of the 1/2, and I need to get rid of the sum a plus b. Now it may help to think of this as just a number. So the first thing I'm going to get rid of is the 1/2. So one way of eliminating the 1/2 is to multiply it by 2. Now if I multiply this side by 2 to get rid of the 1/2, I need to multiply the left hand side by 2. So the 2 and the 1/2 cancel. We're left with h times the sum of a plus b equals 2 times capital A. Now to get h by itself, I need to get rid of the sum of a plus b. So since it's multiplying, I'm going to do the opposite and divide. So I divide both sides by the sum of a plus b. And here is our formula. This formula looks different than the original formula, but it's the same thing. The only difference is this is in terms of h, where the first one was in terms of capital A. Let's do part B. We're going to solve for little a. So we begin with the equation. I want little a to be all by itself. I need to get rid of the h, the 1/2, and the b. So the first thing, just like in the previous part A, I'm going to multiply both sides by 2 to get rid of the fraction 1/2. So now I need to get rid of the h and I need to get rid of the b. So the next step is to get rid of the h. So we divide both sides by h since it's multiplying. Now once the h is gone, we have a plus b. Lastly, to get rid of b, we're going to subtract b to both sides. And we have 2 times capital A divided by h minus b is the same thing as a. Thanks for watching.